Perfect. All right. Thanks everyone for joining. Today we're excited to talk about Snowflake. So I like to typically, if we're presenting in person, before we start, I'd love to do a show of hands. But since we're virtual today, it'd be cool if people could just share in the comments. If you're using Snowflake, comment Snowflake. We'd love to see who our Snowflake users are out there. And if you're using Iceberg, comment Iceberg. And if you're using both, that's awesome. You can comment both as well. So it'll be cool to see in the comments who's using each of these.
Yeah, I see quite a few coming in Snowflake, and then I see at least one person here has mentioned Snowflake and Iceberg. So hopefully this is super relevant for the audience here.
Nice. All right, cool. Love to see that. Now, we'll start with a couple of intros. I can jump in. I'm Andy. I'm a product manager at Onehouse. Been on the team about 2 years building out our managed data lakehouse platform, which you'll learn a bit more about today. And while I've been here, I've had the chance to work with plenty of folks who have been building data lakehouses from scratch, building large scale data systems. And before Onehouse, I have been at a couple different startups and worked at Google in ads and ML ops. Ryan, over to you.
Hi, everyone. Ryan Garrett, working with Andy here. I'm on the product marketing team at Onehouse. Spent about a decade and a half in the data stack at one place or another, whether that's in databases or BI or in the lakehouses. So really excited to see how the space has evolved over the years and what we're at the forefront of here now at Onehouse with open lakehouses, universal data lakehouse, and sort of an unbundled data platform.
Awesome. All right. So today's agenda, we're going to talk about Snowflake and Apache Iceberg. So if you're not familiar with Apache Iceberg, you'll learn about what it is, why it's important, and why has Snowflake been talking a lot about it a lot recently. And if you're already familiar with it, this is a chance to go a bit deeper and learn hands-on how do you implement it and how do you optimize it. So building out your Iceberg strategy is something we'll cover in depth today. Hopefully a lot of hands-on learnings, and I expect folks, feel free to take screenshots of the slides. They probably come in handy as you're building out your own data lakehouse. And then we'll do a speed run demo. We'll quickly talk about Onehouse and show you how to do ingestion with Onehouse and bring that data into Snowflake for queries. All right. So for today's agenda, let's start now with the Snowflake and Apache Iceberg. So recently, Snowflake has been talking a lot about Apache Iceberg. Recently, Iceberg tables in Snowflake have become generally available, and they also have announced their Polaris catalog, which is an open source Iceberg catalog. So Snowflake's really been leaning into this, and probably many folks here have been hearing about Iceberg from Snowflake, but maybe not sure exactly how you should use it or why you should use it. Before we get into that, it's important to understand the origin stories of how Iceberg was created and other data lakehouse formats. So back in 2017 at Uber, they had a massive data lake and they were dealing with challenges, with these large scale workloads, millions of drivers around the world where data was coming in near real time, updating all the time. They needed something beyond a Parquet data lake. So Uber invented what became Apache Hudi as the first open table format or data lakehouse, if you want to call it, which essentially adds metadata on top of a data lake and makes it operate like a warehouse. In 2018, Netflix was facing issues with query performance on the lake, so they introduced Iceberg to help enable performant queries and batch workloads. And then Databricks, the creators of Apache Spark, created Delta Lake, which is another format. And all of these are very similar in the capabilities that they offer and the use cases. So I want to talk about how data lakehouse adoption has been booming. Here's a chart that shows the project stars over time, and we can see these three open table formats have been growing in popularity over time, and they've actually been around even since 2017, used in production at scale. So these are many of the companies to the right here who are using it, like Disney, Walmart, Amazon, Robinhood, Microsoft are using this in production to power their data analytics. And we can see here over time, all of these major projects have continued to grow and continued to be used for the long haul in large scale data systems. We also see here that given these are open source projects, there's a lot of contributors. So you're getting a lot of contributions, diversity in those contributions, and especially with Hudi and Iceberg, many people from different companies have been contributing and continuing to help grow these projects, make them better, faster, more efficient over time. So what is the data lakehouse? What is Iceberg? What is Hudi? What is Delta Lake? Essentially, this is just an unbundling of database management system. So if you see here at the bottom of the graphic, we have data lake storage, so files that sit on an object store. And then what the data lakehouse does is it adds a transactions layer. So you get this metadata on top of the files that enable things like ACID transactions, performant queries, and even performant writes to the tables. You can get data governance for cleaning up old data and adding permissioning more easily. And of course, all the data lives in open source formats. All of these are open source, which means no vendor controls your data. And that's really the theme of what we're going to talk about today. Now, let's talk about why the data lakehouse matters. This is a Snowflake webinar, so I want to focus on, like, imagine you're a Snowflake user or you are a Snowflake user. Something that Snowflake did that was really innovative was decoupling storage and compute. So you could scale compute independent of storage. But one of the limitations that still exists today with a data warehouse like Snowflake and other data warehouses out there is compute and storage are still coupled at the vendor level. So data is stored in a proprietary data format, which means if you have the data stored in Snowflake, you have to use that Snowflake compute, which comes with, its own strengths and its own weaknesses.
Yeah, and that was pretty revolutionary at the time that Snowflake, even though it was still all sort of part of the same stack, was able to separate compute and storage. If you go back to more of the traditional databases like Teradata or sort of the vertical physical hardware stacks, everything was combined. So it's when we saw what we saw with Snowflake unbundling the compute and storage to some degree, when you see how the data lakehouse has really taken that to the nth degree, I think it'll be pretty impressive for folks to see and understand.
Absolutely. So if we look at how data is kind of coupled now at the vendor level, what if we could move to a world where that's not the case? And this is what the data lakehouse and these file open table formats enable. You can store your data on pure object storage. This could be something like an Amazon S3 or Google Cloud Storage buckets. And then you can actually mix and match different query engines. So you can still bring your Snowflake compute to query on those Iceberg tables. And that's what a lot of those Snowflake announcements have been about recently with like the full support for Iceberg tables. But you can also bring other engines like Spark for data engineering use cases or Trino in some cases, if that's more performant or cost effective for you. So you can mix and match and you're not locked into a certain vendor because the data lives in open formats. One of the benefits is that this allows you to use the best query engine for each use case. So we've got a lot of logos on here. I won't go through every one, but I just wanted to illustrate the very rich ecosystem of query engines out there. You have your data warehouses that are great for BI analytics, and this is where Snowflake really excels and has shown its strength. Then you have other types of engines like federated analytics, which might be more cost effective and can help you query across other types of data sources. Or real-time analytics. These are becoming really popular and allowing you to get really fast queries. And then, of course, we have our data engineering, our classic engines there. You have data science. So this is a lot of these engines are becoming extremely popular when it comes to processing data, building ML models, having data scientists be able to access Python libraries that they want to use in their work. And then we see even specialized engines, which can be great for use cases like search or graph. And then local computing. This is an area I'm really excited about. We see a lot of talk about DuckDB and polars, where you can actually run computation on a single node and potentially just run it on your own machine, which can save tons of cloud costs. And the key is that you want to be able to mix and match these query engines based on the use case that you have, not just be locked into one. Now, I want to talk about an example of why use Iceberg with Snowflake. Like, what is one of the use cases for doing this? And this is something that everyone comes to us asking about cost savings. So let's look at an example here. So we start with a data source, and this is an example with the current model with Snowflake. We bring our data into Snowflake through ingestion, and the data lives in that Snowflake format. We'll perform some transformations to clean up the data. And then you transform that data again to make those model tables that your BI analysts are going to go look at. Lastly, they'll go query the data in Snowflake. So this is how we do it today. But with Apache Iceberg, we get more flexibility in this architecture. So imagine instead of data living in Snowflake all along the way, it can actually live in an open table format on your own storage bucket. So when you ingest data, it lives in that open format. And while you transform it, it does. And then you just use Snowflake to do those queries at the end. So your BI analyst gets that same experience, but under the hood, you could be saving a ton of money in this pipeline because Snowflake compute is expensive and sometimes can be overkill for some of these ingestion and transformation workloads, where you might be able to instead bring another engine like Spark, for instance, to do those transformations cheaper, and then just pay the Snowflake compute bill at query time. So I'll pause here. If anyone wants to take a screenshot, take it now. In case this slide's useful. I'll also try to send these out after the presentation. Now, I want to give a second example. So this is using multiple query engines. So let's say you have your data in Iceberg Data Lake, and you want to use it for various different use cases. Instead of copying the data into multiple systems, you can just query directly on one copy of the files. So we have our Snowflake, of course, for a BI dashboards. But then maybe we want to bring DuckDB for some local data science experiments just on a data scientist laptop. And then maybe we want to bring Databricks to do some RAG and some AI workloads that they're really good for, or use MLflow with Databricks. And then Star Rocks. Let's say we have some user-facing reports that need very fast query times, maybe some in-memory processing. Star Rocks can really excel here and give that, and it could be quite cost-effective as well. So this is not just kind of theory. This is something that we're actually seeing across the ecosystem. We see here that almost half of the users who are on Snowflake are also using Databricks and vice versa. And this is just growing over time. And the reason is each of these platforms have their own strengths and weaknesses, where we see in Snowflake is really great at data management, whereas Databricks is really good with data science workloads. And people want to be able to mix and match to the strengths and not have to copy data between them, but rather just query on the same copy of data, which lives in Iceberg or another table format. Now, that's kind of the why. And now let's talk about how do you actually use Apache Iceberg with Snowflake. So let's look at key considerations when building out your Snowflake and Iceberg strategy. And this is one that I expect folks might want to screenshot. If you're building out a business proposal, you need to think about what's going to matter to your leadership. And this is also how we've seen some of the data engineers that we work with be able to rise within their organizations by thinking about some of these higher level impact factors. The 4 key pillars that I've seen are important to organizations are data freshness, query performance, cost, and the ops burden. So when you're building your Snowflake and Iceberg strategy, first, you want to make sure that if you have requirements for processing data in real time or near real time, when the data is created in the source, it should be queryable soon after in Snowflake and on the Iceberg tables. And then when you actually do those queries, you want performance to be fast. Queries should not be slow. So that's another consideration. Of course, cost is important, and this is going to factor in a lot when you're deciding between different query engines to use, and you have to look at the cost profiles of those. And then the operational burden. I think this is one that a lot of folks will run into after they get started. You might kind of try to do it yourself, which can be great when you have access to open source technologies like Iceberg and other engines like Spark. But over time, as you scale, you tend to run into issues. So you need to think about the ops burden. How much expertise do you need to hire on your team, and how much time are they spending operating data pipelines versus building out some of that more unique differentiated value. And this is where vendors can come in handy to help reduce that ops burden. So as part of this, let's look at what Snowflake specifically offers for Iceberg tables. There's two main options. There's the Iceberg external tables and the Snowflake managed Iceberg tables. So here we go. So with the Iceberg, let's look kind of row by row here. The table format support in both is Iceberg. So Snowflake is deeply integrated with the Iceberg open table format. When it comes to data access, external Iceberg tables can be read by Snowflake, but can't be written, whereas the Snowflake managed Iceberg tables you can write. But when it comes to other query engines, it kind of flips. So external tables, these are the ones that live in your own bucket. You have your own catalog. Maybe if you're on AWS, that's a Glue catalog managing. And then Snowflake is really just being used as a query engine. So when it comes to external query engines, like let's say you have your own Spark, you could actually read and write to those tables as an external table. Whereas with a Snowflake managed table, you can only read from those tables, and currently only Spark is supported. So you couldn't go use Star Rocks if you have that Snowflake managed Iceberg table. Performance with the Snowflake query engine. This is the key here. It can be 2 to 10x worse on an external table if you don't optimize that table. But it can actually be similar if you optimize the table. So we'll talk about that in a sec. But the key here is that the table needs to be optimized, and we'll talk through strategies on how to do that. Versus Snowflake managed Iceberg tables, basically they'll just do the optimizations for you. So you'll get similar performance to a native Snowflake table that's in their closed source format. Integrations. So if you're using external tables, you get all the great integrations out of the box that Iceberg offers with all the various query engines. Versus with Snowflake managed, I mentioned you only get Spark, and there are some performance limitations there too. And then on the catalog, external tables can be used with any external catalog like AWS Glue versus the Snowflake managed, which just run on the Snowflake catalog. So catalog also can be a point of lock-in. And if you want to use other catalogs, it's important that you keep that in mind when you're making these decisions on what type of table to use in Snowflake.
Yeah, just emphasizing that point. That's one place that Onehouse can really help you excel to. We announced back in May our multi-catalog sync. So in addition to being able to sync with Snowflake, with Databricks Unity Catalog, Google Data Catalog, you can also sync with things like AWS Glue, Data Hub, Hive Metastore, and then our Apache X table projects that's open sourced with originally with Google and Microsoft, but now we've had a number of partners join us on that. So lots of value in being able to sync across those catalogs.
Absolutely. All right, so let's get into the next step, which is query performance. So this is something, again, I think folks will want to take screenshots of this. So this is based on some internal benchmarks that we've run, as well as some publicly available benchmarks online from Prequel, another startup out there. Query performance with the Snowflake engine is something that's going to be really important. If you have analysts querying data or you have applications running on Snowflake, they should get fast query performance. So let's go from left to right here. We start with Parquet, which is just a raw data lake. This is going to be pretty slow. And when you move from Parquet to even unoptimized Iceberg, you can get a 25x improvement in the query performance. The 25x improvement in query performance. So the key here is that you want to then optimize those tables because you're missing out on a lot of potential performance gains if those are unoptimized. So this means things like clustering and running like table services on those Iceberg tables to improve the query performance. When you do that, you can actually get 2 to 10x performance improvements. And you note here, I've got the Onehouse logo. You could use, you could do this yourself where you might have to kind of tune things and figure it out, or use a service like Onehouse where we'll automatically optimize those Iceberg tables for you. And then you can query those as external Iceberg tables in Snowflake. Now compare that to Snowflake managed Iceberg. You actually get basically equivalent performance as long as these tables are being optimized efficiently And you're going to get similar performance between an external Iceberg table versus a Snowflake managed Iceberg table. So this is something that you might want to keep in mind. And then when we look at Snowflake native tables, which are not in the Iceberg open source format, you can get maybe a 25% performance gain. And this is something the Snowflake team's been talking a lot about, continuing to try and close the gap on. So probably over time, we'll see that Snowflake native gets very similar to Iceberg. So you can really just mix and match and get similar performance. But this is where we're seeing so far. Okay. Now let's look at limitations with the external query engine. So the last slide talked about the Snowflake query engine. But now we want to think about limitations when you're querying with external engines like Spark for a Snowflake managed Iceberg table. Note that the external Iceberg tables are good. They work out of the box and they're kind of standard, but Snowflake managed tables will have some limitations with other engines. The first one being partitioning. So when you partition in Iceberg, this allows Iceberg to actually prune the files. It allows your query engine to prune files when it's querying the Iceberg table. So let's say you want to partition by months, and then you have like a dashboard that's querying only for a certain month. Rather than reading all of the files, it can actually just prune the query and read only the files in the partition. This is something that right now Snowflake does not support for the Snowflake managed Iceberg tables when you're using an external engine. Another problem is file sizing. So with the Snowflake managed Iceberg tables, they try to closely match that Snowflake spec. So the Snowflake file size in their spec is 16 megabytes versus the Iceberg spec, which suggests file sizing around 512 megabytes, which means in some cases you can get up to 30 times more files for Snowflake managed Iceberg tables than for kind of the external Iceberg tables on Snowflake, which means you have to read that many more files, which can slow down query performance. And then the last piece is query engine flexibility. Right now, Snowflake managed Iceberg tables can only be read by Spark. I'm sure they'll plan to add more integrations in the future so you can use other types of engines, but here are a few popular engines here I just wanted to call out you wouldn't be able to use yet with the Snowflake managed Iceberg tables. So this is where external Iceberg tables can actually benefit you greatly. Now let's talk about how do you get the data in. So we're going to talk about kind of cost and that data freshness here. So one option is Snowflake native ingestion. You can do a copy into command or use Snowpipe, which is their file loader for bringing data into Snowflake. You can also use third-party vendors like Fivetran. These have some limitations, like they won't be able to necessarily merge changes. It might be kind of append only for those Iceberg tables and some other limitations. And then Onehouse, of course, also offers fast optimized ingestion into Iceberg. So these are kind of the three categories that you can look at when you're thinking about how do I bring data from sources like a Postgres database or MySQL or Kafka or even just Avro or Parquet JSON files into the Iceberg format so I can query it in Snowflake. Here's a deeper comparison on these. So I'll let folks again take a screenshot if you want to browse this more in depth later, but you see here there are some limitations with each of these approaches for ingestion, some limitations, but one of the great, there's a couple of things to call out. One of the great benefits of Onehouse is your cost performance. So we've heavily optimized ingestion into the data lakehouse tables, whether it's Snowflake, Apache Hudi, Delta Lake. So you can get very fast performance, which means you get fresh queries. You're querying data kind of as it's being created in the source. And then also you're running less compute, so it can be much cheaper. The other key piece is automatic perf optimization. So this is the optimizations that I mentioned back on that previous slide, where you can get the 2 to 10x performance gains over unoptimized Iceberg tables. This is something that Onehouse manages out of the box for you. So you'll always get those auto-optimized tables versus with Snowflake, you can use Snowflake managed, but there are some limitations, like I mentioned, with file sizing and manual cleanup that you have to do in the source itself. And then with Fivetran, there's basically no performance optimization. So you'd have to rely on something like Snowflake managed tables if you want to be able to get fast query performance on those tables. Now, another key piece is, again, on cost. So when you're using Snowflake, Snowflake's designed with this premium compute, which is great for fast queries. But sometimes when you're using it for ingestion and transformations, it can be overkill. We found folks who have used Onehouse for their ingestion in an append-only workload have saved 70% on costs versus using Snowpipe with that more premium compute. And then on mutable workloads, we actually see great benefits as well, because sometimes working with mutable data, especially on the data lakehouse and open table formats, can be quite tricky since inherently a blob storage is immutable. So Onehouse has great innovations that we've built that allow us to really efficiently process these mutable workloads and keep the cost near constant instead of growing exponentially as you expand the data volumes. So especially if you're thinking about large scale immutable ingestion, talk to us. This is somewhere Onehouse can really help. But even on the append-only ingestion, you can get great cost savings by moving from Snowpipe to a tool like Onehouse for your data ingestion. Now I want to look at a case study here, and this is an open source case study. So this is a large tech company who had pretty big workloads. They were storing their data in Postgres as the operational database for the application. And then they were actually replicating that into Snowflake to do some analytics. They were running into challenges with costs, with data freshness, and they also wanted more flexibility to be able to build AI features with that same data. Originally, they started with 5-tran ingestion into Snowflake, and then some more transformations on Snowflake. This was actually very expensive and slow. They ended up moving to a more near real-time kind of streaming-oriented approach where they brought in Debezium and Kafka to replace 5-tran, and then used Apache Hudi open table format to store the data as that like core data layer where they also can perform transformations. And you can kind of sub in Iceberg here as well if that's what you want to use. And then they were able to query the data still in Snowflake and then use Spark for their AI use cases. This ended up saving them, as you see here, over $1 million a year. They cut out that row-based pricing that 5-tran charges, and they moved to much cheaper compute for their ingestion and transformation workloads. They were also able to improve data freshness by moving from these very batch-oriented systems to systems that can process data incrementally. And this also helps with resiliency because once you reach a certain scale, tools like 5-tran start to fall over. And of course, flexibility to use something like Spark for building AI, especially like PySpark. This is something that unlocked new AI use cases for them, and they were able to launch a new AI product because of this. So this is just one example of something that you might want to do for your organization. And of course, I'll call out all of this in kind of the gold box here is offered managed by Onehouse. So if you want to reduce that operational burden, and let's say you don't want to manage Debezium and Kafka for your C2C replication, you don't want to have to deal with the open table formats yourself with writing and optimizing those, Onehouse will manage all of that for you as well. So you can get a similar architecture and similar savings here out of the box. Now let's talk specifically about what Onehouse does. We do a lot of things, but for the sake of this talk, you can think of us as the easiest path to high performance Iceberg tables. And of course, we also offer multiple data formats. So it could be Hudi tables and Delta Lake tables as well, where you saw that all of those are growing in popularity and have been used for various use cases across the largest companies in the world. So what do? We offer managed ingestion, so you can connect to data sources, whether it's streaming sources, databases that you want to replicate, files on cloud storage, or even some of those like tail connectors like Salesforce, and you can bring those in. Onehouse will write them in all three of these major formats: Iceberg, Hudi, and Delta Lake. And this is all powered by Apache Xtable, which we open sourced last year. And Apache Xtable is basically a translation layer that allows you to store just one copy of the data, but translate the metadata between the different formats so you can get access to all three of these major formats with just one copy of data. The tables are optimized, so that you can get fast queries with any engine. You just optimize once, and then every engine can take advantage of those optimizations. So we have folks who are using Trino, Presto, plenty of other engines out there. And then, of course, you can use Snowflake. So you'd use an external Iceberg table. Onehouse manages the table, and then Snowflake reads it as external. So you continue to maintain that choice if you want to use different catalogs and different query engines. And then, of course, you can use data science tools as well. Really bring whatever query engine you want to the data. And all of this is processed within your cloud on AWS or Google Cloud and lives in your cloud storage buckets. So that's the key. The data never has to leave your account. I'll quickly walk through the features that we touched on in a bit more depth. So managed ingestion, we can connect to streaming sources, databases, data lake sources. A few callouts here, we can do very low latency continuous ingestion. So if you want to get that data freshness in just like low minutes, that's something that Onehouse can do for you. For databases, we make it super easy. You just plug in your database credentials and we'll do the rest and bring that in again with fast data freshness. And then we also have tooling that makes it really easy to take a data lake and turn it into something like Iceberg so that you can query it on Snowflake. Here we have table optimizations. So we will continuously optimize those tables that you bring in. So that means you'll get fast queries on every engine, things like file sizing, cleaning up old versions and handling TTL, compacting files to get fast write performance, and clustering for faster read performance, partitioning. All of this is easy and managed in the Onehouse platform. And then something that we uniquely offer, I haven't seen anywhere else in the industry yet, is a multi-catalog sync. So if your organization is using Snowflake, but you also want to expose data to Databricks, we can sync that same table to Snowflake catalog and Databricks Unity catalog, and really any other catalog that you have, all still with one copy of the data. So it's available to you everywhere that your team is working. Okay, so we talked about what Onehouse does, but now I want to give you guys a really quick demo of how you can use Onehouse to bring data from an operational data source into Iceberg tables and then query with Snowflake. So let's take a scenario that's timely as we're approaching the holiday season. This was a real world use case, actually, where a big retailer had thousands of stores. They were scanning 24 million items per hour, and they had to deal with this large scale data, ingest that data and process it in near real time. So let's show how they could do something like this with Onehouse. Give me a moment. I'm just going to move over to next tab. Great. Okay, so this is our Ajax company. We've got a fake company here with some real data pumping in. And I want to show you how you can set up data ingestion super easily with Onehouse. So we'll start by adding a source. And let's say we have a Postgres operational database source. You can just put in information like your database host, all the standard information you'd use to connect. Onehouse will connect, and you can replicate that database into an Iceberg table. So once you've configured the source, you can configure a catalog. We offer plenty of different catalogs, but the key here is you'll want to add a Snowflake catalog. So you can put in your Snowflake credentials, and this will allow us to automatically sync the Iceberg table to your Snowflake catalog. All right, so you got that there. And then you can go into stream captures. So stream captures allow you to ingest data. It could be batch, it could be streaming data into a data lakehouse table. So let's add a new stream and we'll call it test. We can pick our data source. So we've got our retail data. And there we go. So we can do mutable or append only. In this case, we'll do mutable since we want to replicate the original table. And this is actually something that many other products don't do, like Fivetran, for instance, will only do the append only data. But here you can actually merge those updates and deletes on the fly, which is super useful for database replication. Let's take, just take stores. These are all of our stores for the retail. And what it does is it's detected all of the different schemas in our database, and stores is one of those. We can set some data quality validations, so we can actually quarantine bad data if it doesn't match our desired schema, or we can fail the pipeline if that indicates a bigger problem. We'll automatically convert that data from CDC, and if you'd like, you can even add more transformations. We've got a bunch of standard kind of data cleaning transformations built in, and you can even add custom transformations like this one, which will run like a SQL query inline. We've got the data quality validations that I talked about, and then you just set record key, which is like a primary key. It'll read the schema for you, and you can actually just choose your primary key, which could be multiple fields even if you'd like. Partitioning, and then pre-combine, which will help you be able to deduplicate data that's coming in. Lastly, we'll set a data lake. So this helps you organize your data, your database. That'll sync in the catalog and the metastore. And then choose the catalog itself. So we've got an Ajax catalog, which I believe is Glue here. We got our Snowflake catalog, and you can create this to start capturing data. Of course, I've already done this. So we've got a stream capture that's running. If we look into this, we can see data being processed. So you can see records coming in and see the sync duration. So we can actually track data latency and how long our syncs are taking, and commits as well. We can view logs for this, and we can even modify this. If we decide later we need to add another transformation, for example, or add a new catalog, you can do that here. Now let's go to our destination. So on the data page, we can see here all of our tables, and I can actually see this table appearing. So this is appearing as an Iceberg table because we added our Snowflake catalog, and it's also a Hudi table when we sync it to Glue. So this gives a full flexibility into the table formats that we want to have, and we can query this table in any of the major table formats, which is pretty awesome. We see information about the data written. We can see information about inserts, updates, and deletes. Here we can add operations. Let's say we want to add a save point, or we want to manage that data quality. We can see even a history of different commits and table services with information about each. Compaction, backlog. So if we have some files here, this will tell us if they need to be compacted, which will help with write performance. And then partition insights will also help us with our data layout. So one of the key challenges I've seen folks have is, how do you partition data to get great performance? So this can help you handle partition skew and get that observability that you need to get high performance tables when it comes down to the query engines. Okay, so we've got our table here, and I'm going to now navigate into Snowflake. And I'll bring this up here. So in Snowflake, now we can actually run some queries on the table. So it'll take a sec for, okay, cool. I guess my warehouse is already running. So I got a role for this. We've got a warehouse now from this. And now what we want to do is we can actually see these tables. So the tables that appeared in Onehouse automatically appear in Snowflake. So if I look at this, we've got the retail bronze in the Ajax. So retail bronze, we can see all of our tables. So we brought in item categories, item master, and retail stores. If I run this in Snowflake, boom, we get a quick query on this table. And now maybe let's say I want to be able to track the data as it's coming in. So we have data continuously coming in. Let's say we want to just track how many rows are coming in per minute. We can write a query for that, and we can see for each minute how many new rows are we getting. So these are all new scans. Snowflake, we also built a clean table in Onehouse. So the silver table where the data is a bit more prepped. We can look at this and we can query in Snowflake as well. So this is a larger table. It'll just take a moment, and we can see this here. And then the last piece that we might want to do is build a table in Snowflake with the gold table. So let's say we have an analyst who sees the data in Onehouse. It's not exactly what they wanted, so they want to build their own table in Snowflake. Well, you could do that. You could create a new table. You could join your tables from Onehouse, and these are external Iceberg tables in Snowflake. And you're basically just using them to create another Snowflake table, which could be an Iceberg table or it could be a Snowflake native table. I won't run this because this is a very large query, but after you run this, you can, of course, just use that table that you created, and this will give us the top 10 using the gold. It looks like I didn't pre-create the table here, got deleted, but if you run this, you can build the Snowflake table and then you can build an aggregation query. So this kind of gives you that end-to-end flow where you ingest data, transform it, and then use it in Snowflake. Okay, so to close out before we get into the Q&A, which we'll save about 10, 15 minutes for, just to share a bit more about Onehouse, we're getting started here. We have been processing data for some pretty awesome companies across different verticals, whether it's retail, utilities, finance, tech, you name it, we can handle any types of data workloads that you need to bring in. And we're always happy to chat and to brainstorm with you, whether you want to use Onehouse or not, on just your Iceberg strategy, your Snowflake cost-saving strategy, questions about the data lakehouse in different table formats. We're here to talk, and as you can see here, we've had the chance to work with some really amazing companies and work with some very large-scale pipelines. So we have the expertise, and we're here for you. All right. For everyone here, we're happy to offer a free 1-month trial of Onehouse. Just reach out on our site. You can sign up. You can put your info in, and we'll get in touch. We're happy to get you in touch with our expert teams, whether it's me or another expert on the team. And again, we'll walk you through your strategy, answer any questions you have, and really just brainstorm on open table formats and how your organization can use them. All right. Before we get into Q&A, I think Ryan had one call out here on the next webinar.
Yeah, just a little plug for another webinar we have coming up early next month on automated performance tuning for Hudi in particular on Amazon EMR. So we know a lot of people are using Hudi on EMR and got some new solutions out that can really help you optimize your performance and in turn your cost for that setup. So if you're looking at something similar or using that already, definitely worth going to the link you see there and registering for this webinar. And we'll share that after this as well if you don't have time to copy the link. With that, I think, Andy, that was an awesome demo. Really tied together a lot of the content that you presented up front. So some of these questions may have already been answered, but just to double click on them, I'll go ahead and share a few right now. One that we had came in on Zoom is, do you recommend any one format over the other for general analytics or ML use cases? So do we recommend Hudi, Iceberg, or Delta Lake? We do have opinions on those, but we really do kind of work on a customer by customer basis to understand your use case a lot better. Do you want to speak to that a little bit, Andy?
Yeah, I'll go back to one of the slides earlier on. Short answer is they each have strengths and weaknesses. So you really want to dig into what capabilities you need. So we can see here like why they were invented with like slightly different reasons. Uber invented Hudi originally to handle some of this mutable data, but also some of the great things that Hudi offers are like indexing and table services built in out of the box, which is pretty helpful when it comes to just being able to run stuff yourself and being able to get really great query performance. Netflix introduced Iceberg as a simpler layer, so it's easier sometimes to get started with, folks have found, and has some great integrations. And then Delta Lake is really well integrated into Spark in the Databricks ecosystem. So each of them have kind of benefits, but beyond just choosing a format, something that we believe in at Onehouse is getting interoperability between all of these. So Xtable is the open source project that does the translation that we've helped contribute to. And really what you can do is write your data and then read it in all three formats. So you don't have to necessarily choose that format right away. You can focus on how do I get my data lakehouse up and start running, like what vendors are going to help me, and then you can translate the data so you can read it anywhere.
Awesome. Thanks, Andy. Another question came in. Do we have similar metrics, I think, to one of the slides that you had showed? Do we have similar metrics for Microsoft Fabric with Delta or Iceberg? I don't think we have anything. I think Microsoft published a blog maybe this morning that was showing how they were using Xtable under the covers, but I don't, off the top of my head, I'm not aware of any metrics that we have. Do you know of any benchmarks we've been able to look at there, Andy?
I don't have specifics on Fabric. The interesting thing about Fabric, especially if you're a Snowflake user, is Fabric is integrated with Delta Lake the same way that Snowflake's integrated with Iceberg. So a lot of what we said here can apply to Fabric with Delta Lake. And they are using Xtable, as Ryan mentioned, to handle conversions between Delta Lake and Iceberg. So Fabric users can go run queries in Iceberg. If we look again at this performance, where's my performance chart? Here it is. If we look at this, you're going to probably see similar things where if you're doing the conversion through Xtable to Iceberg, you're writing the data with Fabric, and then you're querying it as an Iceberg table in Snowflake. If it's optimized, you'll get the 2 to 10x faster performance versus unoptimized, you'll get that base performance. So make sure that you're optimizing those tables if you are using Fabric.
Here's this is probably, thanks, Andy. This is probably a two-part question. We talked a lot about cost performance, and Onehouse doing a great job at balancing the trade-offs there. But can you talk a little bit about how we do that under the hood? I think you showed the chart where the cost stayed relatively even, regardless of the volume of the total volume of data that was being ingested.
This one,
yeah,
right?
that one there. Yeah. So I think, and then so I think we were relying on the incremental processing there to keep the cost low. But do you want to talk any more about that?
Yeah, so I suggest for understanding how this works, we read about this on the Onehouse blog, so you can read about this. But yeah, check out our blog. But basically, as your tables grow, they get really big. Since you're dealing with immutable data, sometimes when you go and update records, you'll be updating old records and you have to go rewrite data. Sometimes it could be a whole partition or it could be a file. And the key there is processing data incrementally, so you really limit the number of data rewrites that you have to do when you're performing updates. This is something that Onehouse is really great at because of some of the technology decisions we've made and stuff we've built under the hood. So as your tables scale up, your costs for handling updates are not going to scale up versus what we found with kind of other Iceberg vendors out there. Oftentimes you'll have to deal with more data rewrites.
Excellent. And then perhaps building on that a little bit, there was a question that came in about if we were to replicate a rather large table that had a lot of history, but we still wanted to pull in sort of the incremental data to update that table. Do we have any sort of best practices around how you would do those? Would you mix and match Onehouse with other vendors? Would you try to do that all via Onehouse to at Snowflake in this case, or how would you recommend trying to replicate a large historical table and then load the incremental data as well?
Yeah, so Onehouse can help with that bootstrap. We have very efficient bootstrap. If you have like a table that's maybe just a lake table in Parquet, we can bring it in very easily and then continue to run incremental processing for new data into that table. That's something that's pretty common when folks will get started with Onehouse. Or if you've already got a table in one of the table formats, maybe it's Iceberg, maybe it's Hudi, we can also pick those up and help you get started in a similar fashion. So we're built for that, and it works really well. Happy to chat more too if you reach out to us.
And on that note, Andy, I did have a couple attendees ask about how they can get in touch. I shared your email, andy@onehouse.ai. Any other ways that you could suggest that people would reach out to us to either work on custom demos, POCs, or just in general to learn more about lakehouses, lakehouse formats, um,
Yeah.
any of this.
Yeah, so I'm very happy to chat with folks. Reach me at Andy@onehouse.ai and we can have a one-on-one conversation, talk more about this topic. Also, if you're interested in the Onehouse product, the fastest route is to either email gtm@onehouse.ai or just go to our site and you can click on I think there's like an express info button on onehouse.ai. You sign up there and we'll be in touch pretty quick. So those are all the routes you can take.
And sorry, I missed this one that came in a little bit earlier. We talked a lot about the multi-catalog sync and about Xtable, even though this webinar was primarily focused on Iceberg for Snowflake. Do we see a lot of customers out in the real world using multiple sort of query engines where these types of things are important for various use cases?
Yeah, absolutely. This is very common. So the example here is based on what we've seen in the real world. Like these are use cases where folks are actually bringing different engines for different use cases. And then if you look at the stats here, of course, this one just tells a great story about Snowflake and Databricks. People using different formats, Delta Lake and Iceberg, as well as different catalogs, Unity and Snowflake catalog to work with these different systems. Something else that we've seen here is, I'll go back. We got a slide on all the engines. So the key thing when you're getting started with the data lakehouse is to choose your storage format before you choose an engine, because the storage format is harder to change down the line. And with Xtable, you can get interop between the different open table formats. So it's good that you choose one of those to start. But then with these engines, you can often kind of sub them in and out, and you can do a lot of testing over time. So we've seen people start with something like, let's say they bring in their table as Iceberg, and then they test out like a Presto query engine versus Star Rocks versus Snowflake on that same copy of data. So they can actually just mix and match and like kind of run their own benchmarks with different engines on the data that they bring into Onehouse, and then choose the one that works best for them with cost performance. Over time, new engines emerge too. A lot of these are very new. A lot of funding is going into the space from VCs as well. So something else that you can do is like over time, if you find that your engine's not meeting your needs or another one looks interesting, you can test that out on your data as long as it's in these open table formats, and you can even shift down the road. So it's about future proofing your architecture as much as it is getting cost performance in the short term.
Sweet. And to that point, I mean, we showed some benchmarks throughout this presentation, but that's one thing that we always recommend is test your own use case on your own data and establish your own benchmarks. That's ultimately the way that you're going to know you made the right decision in the long run. With that, I think that's all the questions we had come in, Andy. Maybe a couple more that we want to follow up with one-on-one as well. Anything that you want to add, or should we go ahead and wrap it?
No, thanks so much, everyone. Stay in touch. Genuinely do. Please reach out to me. Please sign up. We're very happy to talk. And even if you don't want to use products right now, like Onehouse, we love to just learn from folks and brainstorm, see what people are doing, because it fuels our innovation and helps the community as well. All right. Thanks, everyone.